in this for specifically for these 3 weeks, like for sequence, series, and limit integration, we are not considering 0 as a member of the set of natural numbers. Okay, so you have to exclude 0. Okay. Okay, so let me prove why actually this function is not injective in the set of natural numbers. So so if I take two distinct natural numbers, say A1 and A2, they're distinct, right?
Yes, sir.
And both of them are natural numbers. So that means A1, so either A1 is less than A2 or A2 is less than A1, right?
Yes, sir.
You have a ordering property in the set of natural numbers, so you can compare two elements. So suppose say A1 is less than A2, right?
Okay.
So that means that means what? You can say that 1 by A2 is less than 1 by A1, correct?
Yes, sir.
Right? But and 1 by A2 and 1 by A1, they are certainly less than 1, right?
Yes.
Yes.
Sir.
So then if I add A2 over here and A1 over here, then A1 plus 1 by A1 is less than A2 plus 1 by A2.
Yes.
Is it fine?
Yes.
Yes, sir.
Because see, the difference between A1 and A2 is always greater than or equal to 1, right?
Yeah.
And these two values, the values of 1 by A2 and 1 by A1, they are certainly less than 1. Okay. So if I add A1 here, so A1 plus 1 by A1 is certainly less than A2 plus 1 by A2. So now this is nothing but f of A1, right?
Okay.
Which is less than f of A2, right?
Okay, sir.
So basically what I showed. Can you tell me what I showed here?
So the 1 function.
Yeah, so what basically I showed. So see, you have to see my first assumption. So I took two distinct natural number, right? In the domain, and I showed that their images are also distinct, right? Because I'm getting a strictly less than sign. So certainly f of A1 cannot be equal to f of A2, right?
Okay, sir. Yes, sir.
So what I showed, if A1 is not equal to A2, that means f of A1 is also not equal to f of A2, right?
Okay, sir.
So this means f is injective.
Okay.
So what about now? Can you tell me what about now option 3?
The option 3 was f is an injective function of the domain of
Yeah.
f.
So basically, I have already proved this one. So
Yes.
now, can you tell me the reason?
Yeah, because for every unique A1 and A2 which are not equal, so the mapping of it is less than the other number. So it is injective.
No. What? See, in the option 1, what basically I showed? Image of 2 and image of 1 by 2, they are same.
Okay, this one, yes, sir.
So they are also rational number, right?
Yes, sir. Yes.
2 and 1 by 2, they belongs to Q, right? Q minus 0, right? So that means f is also not injective in the set of Q minus 0, right?
Okay.
Got it, right?
Yes, yes.
Similarly, for the fourth option, like f is not injective, in Z minus 0, you can basically you have to give the same argument, whatever I have I gave for natural number minus 0.
Okay.
Because yeah, so you can give the same argument, right?
Yes, sir. Okay.
So basically, okay, so the option is okay. It's injective. So basically, you can pick two different number in the from this
Sorry
set.
to interrupt you. Can
Yes.
you solve this by using the graph?
Sorry.
By plotting the graph? By plotting the graph of the function, can we check all these options?
You can, but okay. So the thing is, you
Because
don't.
it takes a lot of time now checking every options. If it's easy by the graph, then I think
No, then
it will
for
take less.
no, then for each option, for each domain, actually you have to plot the graph. Like you have to basically, I feel like checking.
This is better.
Yeah,
Okay.
checking is better. Okay, so because it's not that difficult. Like it's clear. Like as you can see, for natural number, we proved that how the function is injective on the set of all natural numbers minus 0. And the same argument, using the same argument, you can show that f is basically injective in this set. Okay, the same argument. Okay, so you pick two elements from z minus 0 and you show that f of a1 is not equal to f of a2.
Okay.
And the next option is f is surjective if the domain is n and the codomain is q.
Q.
Okay, so it's any idea how to solve this one? How to disprove this one?
No.
No, it's pretty easy. Like anyone else, you want to give some reason why this function is not surjective. So
Because every codomain element is does not have a pre-image in domain.
yeah, that is fine, but I just want you to give a element in the codomain which don't have a preimage in the domain. That is
For this
basically
function.
you are saying the definition of surjective function. So I want to disprove this one. Okay, so to disprove this, I have to give you a element in your codomain. I have to produce an element in the codomain, that is Q, which don't have preimage in your domain.
I think the whole set of negative integers does not have a pre-image.
True. In particularly, okay, you don't have to go to negative integer. So 0 don't have a preimage.
Yes.
Okay, it's one element is enough. So as you can see, 0, see, what is f of x? X plus 1 by x, right? So this cannot be 0, right? So already someone said like set up all negative integer rational number don't have preimage. It's quite obvious, right? If I take a natural number, right, a is greater than 0 and 1 by a is greater than 0. That means a plus 1 by a is always greater than 0. Right.
I think
so
we don't need to do this also, na? By checking n q domain, there itself we can strike off it's not surjective.
Sorry, can you repeat?
Function n to q, right? From here itself, q won't have all pre-images in n in the domain.
No, actually you cannot say like that. Actually, there is a bijection from n to q. Okay, so particularly this function is not surjective, but we can produce one function from n to q which is surjective. Okay, so yeah, so I guess that is what you have studied in your week 1 content. Okay, so you can actually, so you know, right, this some cardinality of infinite set is there. Okay, so basically cardinality of n and cardinality of q are same. Okay, you can actually produce a bijection in between n and q. You can give a function from n to q which is biject. This particular function, the way the function we have, so the way we have defined this function is not surjective. Okay.
Can you please define what f colon n?
So this is
right. Yeah, and here is a domain for this function, or can we say that?
So n is the domain of this
sorry
function.
to interrupt you.
Yes.
So n is a
sir,
domain
continue.
and q is a range for this.
Q
function.
is the codomain, not range.
Okay.
So how we confirm this is not subjective? Sorry, can you please repeat? How we confirm this? It's not subjective.
See, basically what I showed. See, if you pick a number from your domain, which is basically the set of natural number, right?
Yes.
So a is always greater than 0, right?
Yes.
1 by a is also greater than 0.
Yes.
So that means f of a, which is 1 plus 1 by a, is always greater than equal to 0. Greater than 0. I is more precisely I can say it's greater than 0.
Greater than 0. Yes.
So then you have 0 here, right? 0 is in the set of rational number, right?
For subjective, codomain should be equals to the range, right? Range
Yeah.
equals to codomain.
Yeah. So basically what I showed, the range is always positive, right?
Yes.
So that means the negative rational number are not in your range set, right?
Yes.
So that means
Okay.
f cannot be surjective.
Okay.
Okay.
Yes.
So for the negative
sorry to
numbers,
interrupt
we do
you,
not have
sir.
a pre-measurement in the domain, right?
Yes,
Hello?
yes. Yeah, please. Hello.
Sir, sir, I just want to I just want to reminiscence that you are about to tell the calculus book name.
Sorry.
Yeah, you told that you will tell the book name of calculus that we have to refer.
No, this I never told, like because I am taking.
It was Srikanth, sir. So it was
Srikanth, sir.
Error change.
Yeah, so maybe Srikanth told you.
In the last session, he told
Yeah,
us.
so. But yeah, I guess I never told you.
Sir, can you suggest any book?
Okay, so
we should
better
follow?
you should ask this question up once
Calculus.
I complete one question. Okay, so since I'm discussing one question, you should not ask like some other thing in between that. Okay, so
Okay.
certainly I will tell you. Okay, but yeah, let me complete this. Okay, so what about option 6? What about option 6? Okay, option 6, you should able to solve option 6 because I already gave you the answer for option 6. Okay.
Yes. Yeah, thank you, sir.
Yeah, thanks.
And so one more question I had. Sir, I wanted to know why is ln of 2x squared plus 10 not a quadratic function? I mean, I plotted on the Desmos, so it had that quadratic curve, but according to the answers, it is not quadratic.
No, what do you mean by quadratic function?
Which must have at least 2 in the power, and if you plot it, it must have a curve.
No, it should be a polynomial of degree 2.
Yes,
right?
sir.
If a function is in this form, ax square bx plus c, where a is not equal to 0, right? Then only you can say that that function is quadratic function, right?
Yes, sir.
Yes, sir.
So when you are saying ln, so what is ln of?
ln of 2x squared plus 10.
So this one is not in this form, right?
Okay, because it
Yeah.
has ln.
Yeah.
Okay.
Yes. So basically, it's not in the form of a polynomial of degree 2. Okay, so since it is not in the form of a polynomial of degree 2, then
Can't you
it's
say it's a polynomial, land functions,
No,
land
no, no.
logarithm?
no. It's a logarithm function. Okay, it's not a polynomial. It's not a polynomial function. Okay. So, for example, sine 2x plus 10.
Trigonometric, okay.
It's not a polynomial function.
And e power x, these are also not polynomial
If I take
functions.
ex square plus 5,
Exponential functions.
this is also not a polynomial function. If the function is exactly in this form, right, then I can say that my function is a polynomial function. Okay, well, like the quadratic function, right? For example, 2x square, if my function is in this form, then I can say that, okay, it's a degree 2 polynomial, it's a quadratic function. Okay.
If my function is ln x square plus ln x plus 5.
No, that is also not a polynomial function. Okay.
Sir, ln 2x square plus 10 is a composition. No?
No, composition function is not a polynomial function. Then you say that I am composing logarithm function with quadratic polynomial. That statement is correct. But when you are saying this is a polynomial function, that statement is not correct. Okay.
Not polynomial is not.
Yeah, it's not a polynomial. Okay, you can say that I am composing one logarithm function with a quadratic function. Okay, that statement is certainly it's true.
Yes.
Okay. Rishabh.
Yeah, hello, sir. Am I audible?
Yes.
Yeah, sir. I have a doubt in activity 7.3, question number 6.
7.3, question number
6. It is asking, sir, about the cardinality of the graph of function f.
Yeah, yes.
I have doubt in question number 8, the same activity 7.3.
Yeah, sir. The question is, hello.
You are audible. Yeah.
The question is, let the function f a to b be a function where a and b are subsets of real number and cardinalities of set a and b are 4 and 4 respectively. Then what is the cardinality of the graph of f?
Yes.
And the answer for this question is 4.
Yes.
I mean, how it is 4? Like in the question number 9, it says the cardinality of the graph could be less than or equal to cardinality of a cross b. So can we say that the cardinality of function where the subsets, cardinality of sets a and b are 4 and 4, can we say that the graph of function, cardinality of graph of function is less than or equal to 16?
Yeah, let's see. When you are saying, even I can say that the cardinality of the graph of the function is less than 20. Even I can say that the cardinality of the function is less than 100. But see, less than is not giving you a fixed value. Okay, it's basically in question number 6. It's asking you to find the exact value of the graph of the function. Okay, yeah. So you need to find the exact value. So when you are saying that the graph of the function is less than equal to something, then it's not a specific value. Okay, it's giving you a range. Okay, when I'm saying x is less than equal to 5, then I'm giving you a range. Okay, I'm not giving you a particular value of x. Okay, so in the question number 6, is basically it's asking you the exact value of the graph of the function, right? And my first question is what is the definition of the graph of the function? What is graph of f?
So the points that is will be on the graph.
No, there is a definition.
X comma f of x.
Yeah, so
yes, sir, x comma f of x.
Yeah, so there is a definition. Okay, this x comma f of x certainly lies in the graph of the function, but yeah. So first you should, when I'm asking about the definition, you should tell me that, okay, this represents the graph of the function where x varies over a, right? So so in the question it's saying that the cardinality of a is okay. Please, whoever is not asking the question, please mute yourself. So it's in the question it says that the cardinality of a is 4, right?
Yeah.
This is my right.
Yes.
So then what will be the graph of the function? What will be this set?
So it's basically cardinality of
A1,
coordinate
F,
pair,
A1,
right?
F of A1. F of A2, yes, sir.
So then what is the cardinality of this set?
Yeah, got it. 4.
Okay, it's basically the cardinality of the cardinality of F is same as the cardinality of A. Okay.
Okay.
So in particular, I can say that it's less than cardinality of A times cardinality of B, right?
Yes, sir. Yes, sir.
So this statement is also true. But when I'm saying it's less than equal to, it's not giving you a particular value. It's giving you some range. Okay.
Okay.
Yeah.
Yes, sir. In question number 8 also, it's asking the lower bound of the cardinality of set A. In the same activity 7.3, question number 8. Yeah. The question is, there is a graph and it asks, let A be a set of points where curve C has no tangent. And the
Yeah,
lower bound for
that is a different question, right?
Yes, sir. Yes, sir.
It has nothing to do with the graph of the function, right?
Yeah.
Yeah. So.
Yeah, sir. I have doubt in the tangent for the floor function, where the question asks left limit, right limit. There I got confused, sir.
No, that is a different question. Now you're now actually basically you are mixing so many things. Okay, so now what is your question? Like,
Okay. But yes, sir.
So now I should solve question number 8 or something else.
No, sir. Question number 8.
So this is the graph, right?
Yes, sir.
So this is a point C. This is Q R S, right?
T.
So as you can see, this point, at this point, the function don't have any tangent, right? At point, because it's some kind of steepness is there, right?
Yeah.
So similarly, at this point, you don't have tangent at Q.
Yes, sir. Yes.
Similarly, at
R also.
R. And similarly, you don't have any tangent at point S. Okay.
Yes,
sir. So see, this picture basically tells you some part of a function, right?
Yeah.
So we don't know what is going on other part, like rest of the part of this function, right? So from this figure, I can tell you that, okay, I have at least 4 points, right? From this picture, I can tell you that I have at least 4 points where the function don't have tangent, right?
Don't have tangents. Yes.
So that's why it's asking you the minimum number. Okay. So from the picture, I can say that by looking at the picture, I can say that, okay, I can tell you that, okay, PQRS where the function don't have any tangent, at least. Okay. So I don't know. Yeah. So that's why the cardinality, the minimum cardinality is basically 4.
Oh,
okay.
Yes. I got it.
Okay.
Yeah. Sir, I have doubt in limits, where the function is floor function and limit about left limit and right limit.
Okay. So yeah, so I'll come to that. Just give me some time, like I'll go to the limit. So before that, I just want to do something from this activity 1, 2, or 3, 1.1, 1.2, and 1.3. Then I'll come to the sequence and limit. Okay.
Okay.
Sir, I have one doubt in this question, sir.
Yeah.
Sir, there is no any graph reference graph is given. Then how can you be plot such type of graph?
No, then you have to draw it's depend like how, see, certainly it's not easy to draw a graph of a function. Like certainly it can be tricky. Okay. So it's depend on the given function.
And in question number 8, sir, there is no any function given or anything about that function is.
Question number 8, where?
7.3. Same question which
The graph
No,
is there. Same
the
graph.
graph
Same
is
graph.
graph is there above question number 7.
Yeah. Read the
Okay.
instructions. Read the
Okay,
instructions.
okay.
Answer the
Okay,
question.
okay. Then okay, then okay. Sir.
Yeah. So yeah, so any other doubt from activity 1.1, 1.2, 1.3?
Yes, sir.
Yeah, 7.1, fifth
Hello.
question.
Just a minute. Yeah, Sandhya, who is Sandhya?
Yeah, 7.1, question number 5.
1, question number 5. Yeah, so what is your doubt?
उधर मैं आया था उधर कर ले यूं चल
Please mute yourself. Like if you are not asking questions, then please mute yourself.
Yeah, actually, how these badminton players act as sets is there, na collection of what are the collections or sets?
No, so the thing is, you have to know, like, so as you know, there is no precise definition of set. Okay, so there is some vague definition of set. See the problem with this say rich people or good badminton player or maybe good actors, these things are not well defined. Okay, so what do you mean by good player? Okay, so there is no parameter to measure good players, right?
Okay.
Good players is not a well-defined term. Okay, see, if I say let's say set up all shorter people. Okay, so what do you mean by shorter people? Okay, so you have to specify something. So what do you mean by short people, or what do you mean by tall people? Okay, similarly, what do you mean by rich people? So maybe for me, the notion of rich is something different from yours. Okay, so that's why these are not sets. Okay, so there is no precise meaning of rich people. Okay, there is no precise meaning of good actors. Okay, but there is a precise meaning of irrational number. Okay, if I'll give you a number, you can tell me that whether that number is rational or irrational. Okay. But I cannot tell you which one is rich and which one is poor.
Okay.
If we can define there's like this much of wealth, we can
Yeah,
call the
then if I can fix, right, the set of all people so that their salary is less than greater than salary is greater than 10 lakh.
Okay.
If it is defined, it will become set.
Yeah, so then I can say that, okay, now I can pick a person. What I need to check whether the salary of that person is greater than equal to 10 lakh or not. If the salary is greater than 10 lakh, then that person is in my set.
Okay.
Okay.
But when I'm saying that rich people, I don't know what do you mean by rich people. Okay,
Yeah,
that's the problem. Okay, so that's why
well-defined collection of items.
yes. So yeah. So the problem. So yeah. So when I'm talking about sets, then should be a well-defined collection of objects. Okay.
Okay. And question number 10. Here 4 options are there. 3 answers are correct, but what is
No,
the wrong answer? It's not mentioned here.
Okay, I guess. Okay, so the
question number 10.
Yeah, so for the first option says this is a injective function, right?
Yes. For non-zero integer.
Where m is
R2R.
M is non-zero, right?
R2R. Yes. R2R.
What do you mean by R2R?
Function from R2R.
Yeah. Yeah. It's a map from R2. Okay. So you can prove that this is an injective function, right?
Yes.
Yeah. So this statement is correct.
All linear functions are injective functions only, no?
Okay. So yeah. So basically, you can say that if your function is of this form ax plus b. Basically is, yeah, so you need to just put a condition that okay, linear function, yeah, if m is non-zero, then it's a 1-1 man. Okay.
Sir, could you please give an idea, injective and subjective, please? Just basic idea.
Sorry?
Injective and subjective, that equations you're telling me, can you give an idea, clarity?
No, so that is the problem. Like there is no there is no some finite methods like I can tell you so that you can check the injectivity and subjectivity. Okay, for different question you have to apply different methods. Okay,
and in the question number 9, first option is there. Any linear function is always an increasing function. It's not true. Can you please explain this?
No, like it's a line, right?
Yes.
So this can be a line, right?
Yeah.
So, but this is not a increasing function; it's a decreasing function, right?
Okay.
So in the same in question 5, all
just a minute.
linear are polynomial also.
If the slope of the function is positive, then you can say that the function is increasing. Okay.
Yeah, it could be even constant, like y is equal to something. That is also a straight line, right?
No, actually,
m is not equal to 0.
No, actually, it's a linear function. So when I'm saying that, so when you are saying f of x equal to c, it's not a linear.
M is non-zero, right? Okay.
Non-zero. Yeah, m is non-zero.
So it's a constant function. It's depend on the definition, I guess. Like
so when it comes to the statement, m not equals to 0 means it may take negative also.
Yeah, that is fine. But
so how it become injective now? When for negative integers?
No,
that is why we are defining.
No, the taking non-negative integer taking 0 has nothing to do with injectivity, right? Because you need to check that two different elements in your domain have different image.
This is one function. Just
we can apply.
Okay,
for just now we you explained that for the positive function, linear function, it is injective.
Which one I explained?
Just now you drawn up. Just
so that is the condition. What
this
we are
one, minus
m is
1.
not equal to 0. If m is equal to 0, then what?
Sorry, which one? Okay, which one you are talking about? Which
just
one?
Beside that, just we draw negative slope line, na? By negative slope line.
No, I am saying this is not an increasing function.
Okay.
And this is 1-1, right?
Yes, 1-1.
And certainly it's taking negative value.
Yes.
So taking negative value, taking 0 has nothing to do with the injectivity of a function. Okay, so the thing is, see, then for injectivity, you have to check that if a1 is not equal to a2, then f of a1 should not be equals to f of a2. That is what you need to check for injectivity. So it doesn't matter whether the function is taking 0 or taking negative, taking positive, it's not an issue.
So all linear functions are injective.
Yes.
Okay.
Okay, so yeah, so what about option 2?
It's a parabola quadratic function saying it's onto function.
Yeah.
When a, b are real numbers.
Yeah, they are arbitrary real numbers, right?
What means arbitrary real numbers?
It should be true for all b, c in R.
Arbitrary means, is there any meaning? Arbitrary?
No, it's basically saying it's onto for all a, b in R.
I think arbitrary means, is there any different meaning?
No. It's basically a and b. They can take any real number. That is what it's saying. Arbitrary means they can take any value from the set of real numbers. Okay. So
it's wrong.
A random real number.
Yeah. So basically, if you take b and a to c to be 0, what basically you are getting? X square, right?
Yes.
No, here you cannot take C0. Yeah.
Sorry, why?
A and B only they are defining to be a half, right?
BC. They defined BC. Not A, B, B, C.
See
Oh,
here,
yeah,
A is fixed. A is always
Ah,
1, so I cannot
okay.
change it. So this is not surjective.
Yes.
So option 2 is incorrect. Okay.
Yes.
Next, go to option
1 by e power x.
Yeah, 1 by x. 1 by e power x
Yes.
is unbounded function. I guess it's also not correct. Okay. So so e power x is what? E power x is always greater than equal to 1, right?
Yes.
So then 1 by e power x is always less than equal to 1, right?
Yes.
Greater than equal to 0, right? Because e power x is always greater than equal to 0, right?
E power, yes.
E power x is always greater than equal to 0, right? If you draw the
Yes.
graph,
Yes, yes.
this is basically the graph. It's always the graph always lies above the x-axis. Okay. So so then 1 by e
But
power
it
x,
won't be equals to 0, no?
it's but this one is correct, right?
And that's what greater
No,
than 0,
no,
but not equals
no.
to
I'm
0.
see when I'm saying that ex is greater than equal to 0. Okay, it can be greater than 0 also, right?
Yes, greater than 0.
I'm not saying that ex is equals to 0. Okay, when I'm saying ex is greater than equal to 0, so then certainly it's true, right? I'm giving you a
Ex
set.
is greater than 0 is true. Ex is not equals to 0, no?
No, when I am saying 1 is greater than equal to 0, what is the problem in this statement?
1 is not equals to 0. 1 is
Yeah, that
greater
is
than
fine.
0.
That is fine. But what is wrong with this statement? I'm saying
It is greater or equal, so it does not mean
It is not.
equal, right?
It is not and, it is or, greater or.
Yes, exactly. It is
Any
greater
one
or.
condition can be true.
Greater than 0 only. Not equals to 0. We should strike off the not equals to.
No,
It means or. The both
not
conditions need not
necessarily.
have to be true.
So you can say that ex is greater than see. I can write this one. Okay, whatever you are saying, this is great. This is true. But whenever I'm writing ex is greater than equal to 0, certainly this doesn't contradict this one, right?
No, just now what you said, 1 greater than r equals to 0. Can you write that? Really, I'm not clear. You please clear me, no issues. Just now you wrote 1 greater than r equals to 0. Can we say that?
Sorry, 1 greater than?
1 greater than or equals to 0. Just now
Yes.
you wrote to explain me.
Yes. This
As
is
per
fine.
my understanding, I know 1 is greater than 0. So I should not write it as 1 greater than or equals to 0.
No, you can write because this basically says it's greater than or equal. Okay.
Okay.
If one of them holds, then you are fine. Okay. Greater than or equal. Okay. Yeah, either it should be equals to or it should be greater than that number. Okay.
Okay.
So yeah, so basically when I'm saying ex is greater than equal to 0, that is also correct because certainly I'm including the case that ex, it can possible that ex is also greater than 0. Okay, so both the things are included here. Okay, so then my value of 1 by x is basically in between 0 to
Yeah, it's a bounded function.
So it's a bounded function.
So does it need to be bounded between two value or only one value works?
No,
bounded.
No, it's if I will say that it's less than 1, then it can go to minus infinity, right? Okay, so
okay.
It should be bounded in both the direction. In the direction of
sine function and cos function, these are not bounded, right? Because
no,
the domain extends.
No, they are bounded.
Minus 1 to 1.
Do we define bounded based on range or domain, sir?
No, it's depend on, see, the boundedness is basically depends on both range and yeah, basically it's depend on your domain, because these domains allow you to extend your value of the function, right?
But here for sin x, what we wrote minus 1 to 1, that is range, no?
Yes, that's the function value,
No,
not the domain.
the range, see how you are getting the range. How you are getting the range. If you apply your function at a point in your domain, then only you will get the range, right?
Yes.
So how, see the problem, see if I define a function f of x, which is x, and if I define the function from 0, 1 to r, this is a bounded function, right?
Yes.
But if I define my function from r to r, so that f of x is equal to x, this is not a bounded function, right?
We
Yes.
not defined the bounds actually.
Sorry?
Defines are bounds are not defined for this function.
Yeah, this is not a bounded function, right? You cannot get some m and some n. Right? Because as x tends to infinity, your f of x goes to infinity. Right? So this function don't have any bound. So this is, so as I said, like it's completely depend on your domain, what domain you are taking. Okay. So if I'll extend the domain, then my function may become a unbounded function. If I'll pick some suitable domain, then I can make my function to be a bounded function. So it's
Can
completely
you please try to take one more example and check, explain as bounded or unbounded, how to check?
No, this one is clear. My question is
Yes.
whether this one is clear. Why 1 by e, why 1 power e pi e power x is bounded function on R. This part is clear, right?
Yes.
No, sir. Sir, this function can go from minus infinity to infinity, right?
Which one?
1 upon ex.
Why? Can go to
1
minus
upon 1
what?
upon e
No,
raised
no,
to the
no,
power.
no. So
ex.
first tell me why it can go to minus infinity.
I'm talking about domain like x. X can take values from minus infinity to infinity.
Yeah, that is fine. Huh?
Yeah, but but the function value will be between a 0 to 1, like by equal to.
Yeah,
1
that's
upon
why since the function value is basically in between 0 to 1, that's why this function is bounded, right?
So with the sin x also, right?
Yeah, sin x is bounded.
Sin x is bounded. Okay, so domain can be like from real line, but that range should be within limit, right? For bounded function.
Yes. For a bounded function, the range of a function should be in a fixed interval. For example, yeah. So as you can see here, the value of the function is basically in this interval, right?
Right.
It's in a fixed interval. It cannot go to infinity. Also, it cannot go to minus infinity. Okay, it's the value of the function is in between two finite number. Okay, so n is a finite
Can you
number.
please
Only
scroll up a
domain,
bit?
right? Sir, it will only include domain values.
Yeah.
Then only
Just a
we
minute.
can
Just a
say
minute.
the bounded, right?
Down. Here f from 0 to 0, 1 to r. So here we are restricting the domain, right?
Yes.
And now what you have said is here we are concerned with range.
So this is a bounded function. Because the range of the function is basically in between two finite value, two finite number.
Between f of 0 and f of 1.
Yeah. So, but here, if I consider from R to R, this is not a bounded function. Okay. So as you can see,
Can we say
Sir,
then?
here you mean to
Sir,
say
can we
this
say
only
then?
domain,
okay,
domain values,
just
right?
one by one. Okay.
Here you mean only domain values for the bounded function, right? Only x values in the function.
No,
Not in the y values.
what I am saying that the boundedness and unboundedness of a function, it depend on the domain. Okay. It's depend on the domain. If I change the domain, then the function can be a unbounded function. I can make a bounded function to a unbounded function. Just now you can see. So in this domain, my function is bounded. But when I'm taking R to be the domain of the function, in that case, the function is unbounded.
Sir,
Okay,
so
that
can we
is- it
say
is totally depend on the domain of the function. If the
Yes.
domain is specified, then only we can say it is bounded within the range. Let us say here it is 0 and 1.
Yes.
So we can it is a bounded function.
Yes,
If the
yes.
here f of x when it is equal to x, so there is no specification what is the domain of the function. So we can say this is unbounded, right?
Sorry.
F of x is equal to x. Here the value of the x, like domain is not specified. F of x is equal to x. Here the second one, r to r function r to r.
So here domain, I have specified the domain, right? Domain is R.
So yeah, but the r is to r, but we have no clue now what exactly the value of r is there. So it is unbounded.
No,
right?
what do you mean by you have no clue about R? Like R you have set up all real numbers. So domain
So
is
this
clear.
Okay, so you mean to say this is also bounded function?
No, why this is bounded? See, what is the definition of bounded function?
Because I do have a specific value, like here 0
No,
and 1.
no. That I'm saying, what do you mean by the bounded function?
Like I do have a range of the minimum value and maximum value, like 0
Yes.
and 1 or something.
Yeah. So is it possible to bound the range of this function?
But here I do have a, like both infinity values are there.
No,
Like
infinity you cannot take, right? So that is what I am saying now. You have some finite value n and some finite value m. Okay, and the value range of these functions should be in between n and m, right?
Okay.
So infinite is not a finite value, right?
Sir, actually I got confused
Sir,
here.
can I ask just one
Just a
thing
minute.
related to this only?
Hmm.
That if we take the domain to be a finite set of numbers, then would it be a bounded function?
If you take domain to be finite, then it's always bounded. Okay.
Okay, and if you take range also to be within a finite range,
No,
then
you cannot.
again it's bounded.
Yeah. No. It's depend. See, if the range is finite, then certainly it's a bounded function. So
You cannot fix the
Range is
range,
also
right?
finite.
sorry.
Even
You can comment on only codomain, right? You cannot define range.
No, if so, first of all, why I cannot if I define a function like this, say 0, 1, 2, maybe say 1, 2, 3, 4.
Yeah, that is the codomain, right?
This is not a function, first of all. Okay, so you have to define your domain according to your define your codomain according to your function. Okay, so if you define a codomain like that, if you define the codomain like this, then this f is not a function. So yeah. So you have to define your codomain accordingly. Okay, you cannot pick anything.
Actually, can you just clear that one? If function is
Sir, I have doubt in logarithms. Shall I ask now?
No,
Yeah, one second.
Sir,
This 1 by e power x. Here, let me clear one thing.
1 e to the power x, what is the domain?
You talk to each other, like why you are asking me questions. Like if you ask like this, then certainly I see most of the things I can't hear most of your questions. Okay, so it's better. See, I cannot teach you how to ask questions. Okay.
Can I clear in this 1 by e power x?
Clear that one, because we stopped there and somebody asked another question that if function is r to r, so is it bounded or not bounded? Like when we are saying the real numbers we are specifying.
So you have a function from R to R, right?
Yeah.
What is your function? What is your function? What is f of x?
F of x is equal to x.
Yes.
So here we can say x value can be ranged from any values from the first R to second R. So
what is this set? What is this set? What is image of x? What is image of f? What is this set?
Like the values of x will be belong to R only.
What is, no, I'm asking what is this set? What is this set? What is this set?
It is a finite set.
It's a finite set.
Yes.
So n is a subset of this or not?
Yes.
N is a subset of this.
Because real numbers, whatever we
So
have,
then N is a finite set.
yes,
N is a finite set.
natural numbers set will
Is a
be,
finite set.
No.
it can go to infinity also, positive side.
What is this set? What is f of x?
R.
What is it?
Minus infinite to plus infinite.
Right? So this is
Yes.
what is this? This is exactly R, right?
Yes.
So R is finite set, you are saying?
No, sir, it is infinite set.
No,
Sir,
I'm
I'm getting
asking.
confused. Please clarify
No,
this.
you see this. See, if you are confused with the cardinality of N and R, certainly I cannot help you. Okay, so this is, see, you should at least tell that you should able to tell that the cardinality of N is infinite. Okay, so then basically I have to tell you all the things from week 1. Okay, so see, R, certainly the cardinality of R is infinite. It contains all the real numbers. In particular, it contains 1, 2, 3, all the natural numbers. Okay, and clearly the set is infinite. And clearly the set is bounded, because I cannot give you some M and N which are in R, so that R is inside this interval. Right? What do you mean by a function is bounded? Function is bounded if the value of the function is basically in between two finite number. And what is R? R is basically this interval. It's unbounded on both the sides. Okay, it's unbounded on the right hand side and unbounded on the left hand side. Okay, so then I cannot give you some number N and M. So for example, if I take M to be some 10 power 10 and N to be some minus 10 power 10, then my f of x is not in between these two numbers. Right, because f of x can be, so here f of x is basically, this image is basically R. So f of x can be 10 power minus 10 power 100 also. If I take x to be 10 power minus 100, so f of x is basically minus 10 power 100. So I can get a x such that f of x is less than this. Right. So my image is not in an interval. It's basically its whole real number. It's not bounded. Is it clear? Hello. Hello. Am I audible?
Yes.
Yes, yes.
So is it clear like why this function is not bounded?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
My doubt in 1 by e power x. Can you
Yes,
go
yes,
once again?
yes.
What happens when R is negative?
Okay, let me.
Because we checked only R as positive.
No. This is your e power x, right?
Yes.
So
Ours is e power minus x. 1 by e power x, our function.
yes, that is true. E power x. This is always greater than 0, right?
Yes.
This you agree that this is always greater than
Yes.
greater
Yes.
than 0?
Yes.
Okay, just a minute. Like this question is asking you from the positive real numbers or like?
Yeah, the whole R.
Okay.
That's what again I check. It's R. So it's unbounded.
Yeah. Actually, here I have
I think we checked only for positive.
positive real number. I made a mistake. This is true for positive. Real number. Okay.
So e power x and e power minus x both are unbounded over R. Yes. Now clear.
This function is unbounded.
Yeah.
On R.
The same with e power minus x also.
Yes.
So can we say in general over upon R, e power x, a power x, logarithmic, ln, all these functions are unbounded?
Certainly, logarithm is not defined on whole real line, right? So it's defined on only the positive real numbers, right? And in positive real numbers, it's certainly unbounded. Yes, that is how you define this logarithm function, right? So so as I said, like the boundedness and unboundedness of a function, it's depend on your domain. Okay, if you change the domain, then this function become an unbounded function. If you change the domain, that unbounded function can also be a bounded function. Okay, it's depend from where you have defined that function. Okay.
If our domain is bounded, then only there is a possibility for function.
No. That certainly you cannot tell anything from the domain. Okay. If the domain is finite, then you can certainly say that the function is bounded. Okay. Otherwise, if the domain is bounded, for example, if I take 1 by x and maybe say I define this function from 2R. Okay. This is not a bounded function, right?
1 by 0, infinity. Okay.
Because if x goes to 0, then f of x basically
infinity
goes to infinity. So the image set is not bounded. Okay, it's a unbounded.
But here we wrote open bracket. Now 0 is not included. Then 0 we should not take. We should start from 0 point something.
No, that's why 0 is open bracket, right? I'm not including 0.
Sir, why is the 1 also open bracket? Because if x is equal to 1, fx will be 1. Why?
No, I can define a function. I don't care whether it's not nothing. So the main point is that 0 is an open bracket. You can take 1, or maybe you can take some 5 here. Okay, you can take 100
sir.
here.
Yes. Okay, sir. So in any way, it is a unbounded.
Yeah. So it doesn't matter what you are taking on the right hand side, whether it's a open bracket, it's a closed bracket. It doesn't matter. The main point is the left hand side. Okay.
If it is closed bracket of 0, then what happens?
Then this is not a function. Okay, because at 0 the function is not defined. Okay, so it's not a function. So if it is not a function, then there is no point of this unboundedness and boundedness. Okay, so boundedness and unboundedness we can only talk about a function. Okay, so
okay.
Sir, if it is R, then it is also not a function, right?
Sorry?
In place of 0 to 100, if it is R.
In place of 0 to 100, yeah, see, if the 0 is 0, if 0 is in the domain, if you are including 0 in the domain, then certainly it cannot be a function, because f of 0 is 1 by 0.
Yeah,
It's
yeah,
not defined.
absolutely.
So it doesn't matter you are taking R or you are taking Z or you are taking Q. Once you are putting 0
Okay.
in your domain, then that is not a function. Okay, you cannot define.
Okay, sir. Yes, sir.
Sir, one more follow-up doubt. Like when we have this f value, no, 0 and 100, and we need to put in the this f of x is 1 by x, may we will put that value. Then we will say whether it is defined or not defined.
Yes,
Let us
yes.
say, like as you said, it doesn't matter the next one whether it's R or Q, like that. But here we will see only the values, like 0 comma some whatever value is given. We need to put that value in this equation. Then only we will find it out. Right? That?
Yes, yes, yes.
Basically, and if we do not have any specific, like if we have a range, like as you given an example, 10 to the power minus 10 and 10 to the plus 10. So in between that, any value can happen. So we have no idea whether it will be a bounded function or not, because we have no fixed value for that.
Exactly, because see the problem is what is the problem here? See, if you draw the graph, let's say, see this value f of 1 by x. So if x increases, right? If x increases, the value of f of x decreases, right? If x is large, then 1 by x is small, right?
Yes.
If x is small, then 1 by x is large, right?
Yeah.
So the graph is basically the graph of 1 by x should look like this. Okay, so you will get a
strictly decreasing, sir.
Yes. So as you can see as x approaches to 0. Okay, so the f of x basically it's going towards infinity. Okay, so you cannot bound that function. Okay, there is no number such that f of x is basically less than that number, less than or equal to that number. Okay. So that is the problem. That's why I can say that this function is unbounded. Okay, I cannot give a upper bound. Okay, I cannot give a number m such that f of x is less than m. Okay.
Okay. Thank you, sir. Thank you.
Certainly this function has a lower bound, right? This function is always greater than 0, right? Greater than equal to 0. Okay. This function has a lower bound. This function is always greater than equal to 0. But this function, this f of x is equal to 1 by x, don't have a upper bound. Okay, in this interval, say 0 to 1. Okay. In this interval, it don't have a upper bound. As you can see, as x goes to 0, this value of the function goes to infinity. Right? So to prove that a function is bounded, you have to always produce a lower bound as well as a upper bound. If you can do that, then only you can say that that given function is bounded. Okay. If you cannot do it, then that function is not bounded. Okay. So as I have explained here, so for this function, I have produced a lower bound as well as a upper bound. So for this function, 0 is a lower bound, 1 is a upper bound. Okay, the value of the function is always in between 0 to 1. That's why you say that this function is bounded. For example, if you take sin x from R to R, see if you see the graph of the sin x, basically kind of periodic graph you will get. See, as you can see, the value of the function is basically always in between 1 to
minus pi by 2
to 1 to minus 1.
Yes,
Okay.
sir.
So f of x is always less than 1 and greater than minus 1. So I am giving a lower bound. So here my lower bound is minus 1 and here my upper bound is 1. The value of the function is always in between minus 1 to 1. That's why I can say that my function is bounded. And this thing, I cannot do it here for this function. For this function, f of from R to R, f of x is equal to R. I cannot give you a lower bound as well as I cannot give you a upper bound. Okay, so that is the issue. Okay, so any other questions?
Yes, sir. Activity question 7.27.
7.27. Yeah. So what is your doubt here?
Sir, doubt is for the correct answers. They are saying second option is correct. F, if f n function f n to z well defined. So, sir, composition it is taking as f of g, right? Okay.
No, the composition of f and g, I guess Sir has defined it, is basically g compose f.
G compose f.
Yeah.
Or f compose g.
The composition of f and g is defined like this. Okay.
Okay. Okay. I am taking it as f of g.
Okay, so yeah, like basically if you, okay, so the main reason why actually we have written like this, if you go back and check the lecture, there actually Sir actually he specifically he mentioned that the composition of f and g is defined like this. Okay.
Okay.
So in this case you have to check that whether image of f is inside the domain of G. Okay. Then only you can compose two functions.
G of f to be well defined, the range of the domain of f should be the subset of range of G, right?
No, it should satisfy this condition, whatever I have written.
Image of f should be the subset of range of G. Sir, can you please explain this?
No, how you are defining this? You first you are first you are calculating f of x, right?
Right.
Then you are applying G on it.
Yes.
If f of x is not in the domain of G, then how you will compute this one? So you need this condition, right?
Right. That's what I am saying. The range of f of x should be in the domain of G.
Yeah, that is what I have written, right? Image, basically, this is image is basically range.
Right. The range of Z. The range is Z. Okay. Got it, sir. I am taking it as f of G actually. That's why I'm.
Yeah. That is fine. Yeah. I guess some confusion is there in that.
The way question is written.
Yeah. So okay. So so any other questions?
Sir, question number 11 of the same exercise.
Which one? 2.
It's 7.2.
Yeah. So
the expression was getting too complex, and I was not able to simplify.
Right, this is what f is, and it's saying if (3x plus 4), what is the value of this a? So what is f of x?
F composed of
Yeah, that
F,
is
like
the definition. Yeah. So what is f of x?
x by x plus a.
అసలు
Please mute yourself.
ఏం చేస్తున్నావు అబ్బా అమ్మ అబ్బా
Mr. Balu, can you mute yourself?
Okay, so now what you need to do? You need to substitute value in place of x, right? This is your x.
I did that, sir.
Yeah. So then what you will get? X by x
plus a by x by x plus a plus a.
Plus a, right? So then what you should get? X by x plus a into x plus a, right?
Yes, sir.
So this is x ax plus a square, right? Correct? Hello?
Yes, sir.
Yes.
Yeah. So then you just need to equate this one with this one. Right? It's saying basically this is equals to x by 3x plus 4, right? So then what you need to equate? So basically this is basically x by x into 1 plus a square, right? So that means a square is equal to 4 and 1 plus a equals to 3, right? And from both, if you solve these two things, then you will get a to be 2, right?
Got it, sir. Got it.
Yeah.
Sir, I have one general doubt, actually. Suppose there is an equation root over x square plus 4.
Root over of x square plus 4.
Yeah. So now if we want to take x square common out of it, like x common out of it, so if it the answer is mod x, how that mod x came to be, I didn't understand.
No, the thing
why
is,
it's not only x.
No, like the way we have defined the square root of x, we are always taking to be a positive number.
Okay.
That's why. So if you take x, then x you may get some negative thing. Okay, by definition, square root of x is always greater than equal to 0. Okay.
Okay.
Yeah.
Thank you, sir.
Yeah. So any other question?
Sir, activity question 7.4.1.
7.4.
0.1.
Question number 1, right?
Right.
Yeah. So. Okay. So what is your doubt in this question?
Sir, my doubt is how we define sequence. Proper sequence, right? Then why?
Okay, is it like the sound is coming from my side or from your side?
Hello.
Hello. Yeah, Prashant. Yeah.
Yeah, sir. Sir, they are saying N to R is a well-defined sequence. Right? So why can't R to R?
No, what is the definition of sequence?
Sequence is any ordered sequence of any values.
No, like if you see the lecture, so SAR actually basically it's they define sequence as a function from N to R.
Negative values cannot taken. I'm not getting y and 2r. So that is what my doubt.
That is how we define sequence. That is how we define sequence. See, what do you mean by sequence?
Sequence is in some ordered list which have some like pattern.
Right? This is how you write the sequence, right? You have A1, you have A2, you have A3, you have A4, and so on, right? So basically, how you are defining this one? So you can define this as a map from N to R. So how you define f of 1 is A1, f of 2 is A2. AN, right? This is how we define sequence. So sequence is basically it's a map from the set of natural number to R, right? So this is how we define sequence.
It should a whole number like and
no, the image. See this A1, A2, they can be anything. They can be anything from the real number, but the index, whatever you are using, they cannot take anything. We are taking the index from the set of natural numbers.
Okay, index should be the whole number of like positive.
Yeah. So okay.
So 7.4.4.
Okay, any other doubt?
Yes, sir. I have a doubt in activity 7.5, question 3.
7.5, question
3.
Yeah.
Yes, sir. So before the question, I had a doubt that when we say a limit exists, we say that the left hand limit, the right hand limit, and the limit at that point, the same value should come, right?
Yeah, if the left hand limit and the right hand limit, they are same, then you say that the limit of the function at that point exists.
Okay. So in this question, the second option, they have written that limit at x tending to 0 f of x is equal to 1. So we are getting that option as wrong because the left hand limit and right hand limit are not equal, correct?
Equal, yes, is true. But as you can see, like if x is equal to less than 0, the value of the function is -1, right?
Okay.
This is
So,
mine.
So one more question, same exercise, question number 6. It is given that f of x is equal to x square upon mod of x, right? They are given here that x tends to 0 f of x. I had a question for if x tends to infinity, the function, what would be the value? It will also tend to infinity only?
Yes, true.
Okay. Got it, sir.
But the limit of this function exists at 0, right? Because
yes, at 0 it exists.
Yeah.
Okay.
At infinity, it's certainly with the So if you go towards infinity, the value of the function is certainly it will go towards infinity.
Okay. So in last question 10 also same exercise. So in that question number 10, in the second option, they have given that limit x tends to infinity x square upon 1 plus x is equal to 1. Have they used something like infinity upon infinity square upon infinity, something like that? I didn't understand what have they used.
You are talking about this one, right?
Yes, sir.
So basically, if you see, if you divide by x, what you will get? X by
1 by x plus 1.
Right? This is what is. So as x goes to infinity, okay. So this goes to 0, right?
Yes.
But so the below one goes to
1.
But this one goes to infinity, right?
Yes.
So that means the whole expression goes to
infinity. Okay. Got it, sir.
Yeah.
So my doubts are clear.
Yeah. So, okay. So any other doubt?
Sir, 7.4.2.
7.4?
0.2. Second question.
Second question. Yeah, what is your doubt?
The limit of the sequence an. So, sir, we should take as n tends to 0. We will calculate the limit. Like I'm not getting the limit of sequence.
Okay, like I have one question. Have you checked was the video lecture?
Yes, sir, I checked.
So how you compute the limit?
Limit, sir, we will check the numerator and denominator separately first. Like an 3n square plus 5n plus 2, we will.
What is the
check
limit of this sequence?
That is not I am getting, sir.
Yeah, no, then I'm asking about this one. What is the limit of this sequence?
one?
This an is n. What is this sequence? First, can you tell me what is this sequence? Can you tell me all the term of this sequence?
Sorry, sir. What is?
What are the terms of this sequence? What is the first term of this sequence?
1.
1. What is the second term?
2.
Okay. Okay. So then, can you tell me now what is the limit of this sequence?
Sorry, it will go up to infinity, no limit.
Yeah. So as n tends to infinity.
Yes.
N tends to
infinity.
So that means the limit
is infinity. Limit tends to infinity.
Yeah. So as n tends to infinity, the an tends to infinity, right?
Right.
So basically the limit doesn't, okay, in some sense limit tends to infinity, or you can say that limit also
Limit
doesn't
does not
exist. Yeah.
Right, right.
What about this one? What is the limit of this one?
As n tends to infinity, it tends to 0, sir. 0.
Yeah. So basically, if you see the sequence, if you see the what the terms of the sequence, what you are getting first 1, 1 by 2, 1 by 3, 1 by 4, so on. So basically, if you increase the n, the value of 1 by n basically it will decrease, right? So as n tends to infinity, 1 by n tends to 0. That's why the limit is basically 0.
Right, sir.
So similarly, if you go to the question number now, so now can you solve question number 2? What is your an here?
An is 3n square plus 5n plus 2.
2.
Right. 6n square.
Oh. Right?
Right, right.
So now if I divide 1 by n square on both the side, so basically in the denominator and in the numerator, so what I will get?
We will divide by n square, right? 3 plus 5 by n plus 2 by n square, right?
This is 6, right?
Okay.
Right?
Okay, this will 0.
So as n tends to infinity,
this will 0.
This will 0 and this will 0. This will go to 0, right? So then,
okay, sir.
So the limit will go to 3 by 6, which
3
is
by
basically
6.
half.
0.5.
Okay.
Okay, sir. Got it. Thank you. Thank you.
Yeah. Okay.
Sir, could you do question number 3 for the same activity? AQ 7.4.
Okay. So, so some sequence is given here. So you need to find which of the following option are actually subsequence of the given sequence, right? So we have defined a sequence. What is sequence? The sequence is 1, 2, 1, 2, 3, 4, 5, 6. Basically, the nth term of this sequence is n, right? So A1 is n1, A2 is 2,
Yes.
A3 is 3, and so on, right? So we need to find which of the following are subsequence of this sequence. So the option 1 is basically
2, 2, 2, 2.
2. So my question is whether this can be a subsequence of the above one.
Doesn't look like it.
B1 is 2, B1 is 2, so B2 is 2, B3 is also 2, and B4 is also 2. All the terms of the sequence are 2, right?
Yes.
So what is the definition basically? Can you tell me what is the definition of subsequence?
What I understood was that subsequence is sort of a subset of that.
It's
the
basically
sequence.
it's a subset of that. And as you can see, you have some order in this sequence, right? You have some order in this sequence, right?
It's incrementing. Yes.
Yeah, so this is the first term of the sequence, right?
Yes.
This is the second term of the sequence. This is the third term of the sequence. Okay.
Yes.
So subsequence is basically it's a sequence. So subsequence is basically it's a sequence which you can form from the original sequence.
Okay.
Original sequence by deleting some of its term.
Okay, but not adding terms.
Some of the elements of the original sequence. So this is my original sequence. But again, you have to make sure that the order, okay, the order of the element,
yes,
that is the relative position, are preserved.
Okay. So we can't have all the terms same in this particular subsequence.
Exactly. So first of all, like, yeah, so basically, okay. So if I remove this one, I'll get 2, right? So then I can get B1 to B2. That is fine. But after that, you can see that
it should increase.
No, see, as you can see that 2 doesn't appear after A2, right?
Yes, yes.
So then I cannot bring one more 2 here. Okay. After getting a 2 here, which I can say that, okay, I got from this one, from this second term, I got this B2. But from where I can get this one?
Yes.
I cannot get this one from this sequence, right? Because after that, there is no 2.
So at some point again, there should be another 2.
Yeah. So at some point, then only you can, okay, suppose you have 2 here, then what you can do? I can remove these 2 things. I can get 2 here. Okay. Because it's saying that you can delete some of its element, but you should not disturb the position, right?
Okay. And likewise for option 3, because it's disturbed the order and plus it's repeated 10.
Yeah. So what about option 2?
Option 2 is existing in that sequence because we're just
Yes.
deleting the odd numbers.
Yeah, and as well as also we are preserving, we are
The
basically where the order is also preserved, right? We are not disturbing the order. Suppose, okay, next question is, can I say that 4, 2, 6, 8 is a
No.
subsequence of this sequence?
No, it's disturbing the order.
Because as you can see in the original sequence, if you see 1, 2, 3, 4, 5. See, as you can see here, 4 appears after 2.
Yes.
Right. But in this sequence, I'm writing 4 before 2. So basically, I'm not preserving the position of the elements of the original sequence. Right. So that's why this cannot be a subsequence. Clear?
Yes, sir.
So okay, so what about option 3?
Option 3 again, like I said, it's repeating 10, which would not be repeated in the sequence, and it's also disturbed the order because 10 is coming before 4.
Yeah, so basically it's it's basically so as you said, the order is also not preserved, and also we are writing 10 one more time. Okay,
Yes.
which
which would not be there
because so as you can see in your original sequence,
there's no repetition.
Yeah, there is no repetition. Yeah. And what about option 4?
Option 4 is fine because it's just deleting all the even numbers and it's preserving the order.
Yeah, so we have this and yeah, basically I'm removing the first 2 number from the original sequence. I'm getting 3. Okay. Then I'm removing the fourth 4. Then I'm getting 5. And similarly, you can proceed. Okay, you can get the original sequence without violating both the conditions.
Yes, sir.
Yeah.
Thanks.
Yes. So then similarly, you can solve question number 4, right?
Sorry, of 7.4?
Yeah, question number 4 is also asking a similar kind of questions, right?
Yeah, something similar.
Yeah, so it's basically it's asking you have a sequence n square. So an is n square. So which of the following can be a subsequence of n square?
First and second, definitely.
Yeah.
Third one, I don't think so. Neither would fourth one be unless there's an overlapping.
So what about question? What about option 4?
I don't think so. No.
Yeah. So basically, what is there? A1 is what? So in the original sequence, A1 is 1.
Yes.
A2 is 4. A3 is 9.
Yes.
Right.
Oh.
If you take the sequence Bn, which is basically let's say NQ. So what is B1? B1 is 1. So this is fine.
Yes.
B2 is
9.
8.
Oh, sorry. Yeah, sorry. 8.
Yeah, certainly 8 is not there in the original sequence, right?
No.
So then certainly it cannot be a subsequence. Okay, so I guess you can do it.
Yes. Yeah, thank you.
Yeah, thanks. Okay, any other doubt?
Hello, sir. Hello.
Yeah.
Yeah, sir. I in the starting I asked the doubt about the graph limit. Yes, sir. Like in floor function, when it asks for like left interval or right interval at a particular point.
Can you give me some specific example? Like you are taking the greatest.
Yeah. I'm saying like activity question 7.5. Question number 3. Like in fourth option, third option, like left limit, right limit.
7.5 question number 3.
Yes, sir. Fx1 and -1. Yeah, sir.
Yes.
Actually, I'm not getting it.
Yeah, I'll explain. So so this is 0, this is 1, this is 1, it's 2. Let me just do it for 1 and 2.
Yeah, just.
So at 1, the value of the function is 1. Okay, so that's why.
Yes. 1 is included.
Yes. So this is 3. So okay, at point 2, the value of the function is 2. Okay.
2. Yes.
So my question is, what is the left hand limit? Not left hand limit. Let's say, what is the right hand limit of the function? Right hand limit of f at x equal to 2.
2.
Why?
Because at f2 equals to 2.
No, that is not the definition of right hand limit, right?
Oh yeah, from right side approaching to.
So as
x.
you need to check, as x approaches to 2 from the right hand
side. Yes.
What is the value of, so what f approaches? Okay, as x tends to 2 from the right hand side. You need to find where f of x approaches, right?
Yes, sir.
So so as you can see, like when you are coming from 2 from the right hand side, so the value of the function is basically 2, right?
Yes, sir.
So this is 2, right?
Hmm.
So then f of x approaches to 2, right?
Yes, sir.
So that means, what is your right hand limit? Then what is your right hand limit? Hello?
Yeah, hello, it's 2.
Yeah, because that is the definition of right hand limit, right? You need to find as x approaches to 2 from the right hand side, where f of x approaches, right? So as you can see, if you are coming to 2 from the right hand side, f of x actually it's going towards 2. It's basically exactly 2. It's not going towards anything. It's basically exactly 2.
Yes.
So that's why the right hand limit is 2, right?
Yes.
What about the left hand limit?
At 2. 1.
So as you can see, from if you are coming to 2 from the left hand side, so the value of the function is 1, right?
Yes, sir.
So that's why the right hand limit is left hand limit is 1. Two minus, it's 1. So both are different, right? The right hand limit. So that's why if the right hand limit and left hand limit, they're different, then certainly the limit doesn't exist, right?
Yes, sir. At that point, limit doesn't exist.
Yeah. So you can say that at 2, limit
doesn't exist. Basically at 2, the f of 2 is jumping.
Yes, you have a jump there. Okay, so if you are coming, as you can see from you, if you're, so that is basically the left hand limit and right hand limit will give you whether at that point you have a jump or you don't have any jump. Okay, so basically
Maybe break.
Yeah. So so basically, yeah. So if you are coming from the left hand side, the value of the function is 1, and if you are coming from the right hand side, the value of the function is 2. So you have a jump here, and that sudden jump. That's why the limit doesn't exist. Okay.
Yeah, I got it. Thank you so much, sir.
Yeah.
So I have one more question. In activity question 7.3, question 7, you were talking earlier in the beginning of the class on that straight line kind of curve. So I didn't understand why there is no tangent at PQRS. I mean, earlier we in the videos we saw that sir was saying that it doesn't matter that the tangent intersects the curve at some other point, but it should not, touch any other point near that point where it is tangent. So why isn't this? Why isn't there a tangent to the curve at that peak?
Okay, so
P?
the thing, yeah, the okay, so the thing is, still now, sir, I guess, so I guess maybe in the next week he will define tangent formal. Okay, so you need the notion of differentiability to define that tangent thing formal. So the main problem is, as you can see. So when you have a point like this, okay. So then you have a sudden movement. Okay, you have a sudden movement happening here. Okay.
Yes.
Suddenly, so it's basically increases from the left, and suddenly it's started decreasing. So that is the problem. So when you have a situation like this, then you can have multiple tangents. Okay, so as you can see, this can be also a tangent. Okay, this can be also a tangent.
Okay, and at a single point there should be only one tangent.
Yes, so that is the reason. Like you say that a point has a so you say that there is a tangent when you have a unique tangent. Okay, because that notion of that tangent is basically related to your notion of differentiability. Okay, so when I have a situation like this, then basically I can say that okay, this is also a tangent, and this is also a tangent, and also I can say that this is also a tangent. So you have basically infinitely many possible tangents. So that's why we say that at this point you don't have any tangent. Okay, because
so we have to make sure that the curve does not have a very sharp peak or
exactly.
okay.
So sudden movement, or maybe basically as you said, some kind of sharpness is not there. Okay, maybe like this, or okay, if the curve is smooth, then certainly, like if your curve is like this, then yeah, this you can say that as at each points the curve has a unique tangent. For example, if you see the graph of sine x or maybe cos x,
yes, it's not sharp.
Yeah, so that's why, yeah, so that's why actually, so you'll learn like how. So basically, if I have a curve like this, then basically I can prove that the function is not differentiable at this. Okay, so
First
Okay,
of
so
all,
when we learn
it is
differentiation, that is when this will make more sense.
Yeah, exactly, because see, the tangent is basically is giving you the slope of the tangent is basically giving you the value of the derivative of that function at that particular point.
Okay.
So first of all, the function is also not well defined, or is it not even a function here, right?
No, why it's not a function?
If it has sharp corners, there was something discussed in
Not a
quadratic
curve.
approach.
It is a function, but it's not a curve.
It's a function.
Not a polynomial.
Polynomial.
Polynomial. Function.
Certainly it cannot be a polynomial function. So its polynomial function is always smooth. Okay, you cannot have some sharp edges in your polynomial.
So that definition was in reference to only polynomials, is it?
Yes.
This cannot be a polynomial function, but certainly this is a function, because if I draw a line which is parallel
Yeah, horizontal, vertical line.
Yeah, it's basically it cannot touch the graph more than 1 point. So certainly this is a valid function, but yeah, certainly it cannot be polynomial function. Okay. Because
that condition was specific to polynomial functions only.
Even not polynomial, like you can say that the function, some kind of smooth function, like maybe polynomial sine x, log x. Okay. So because they are smooth function. Okay, this is not a smooth function because you have a sharp edge here. Okay. So that's why this.
One quick question. So if a curve is smooth, we can say that every point on the curve has unique tangent, right?
Yes.
What if the tangent is vertical to y-axis? Do we say tangent exists?
Sorry?
If the tangent of a curve is like parallel to y-axis, does that affect the tangent being
no
existing?
like okay, there are okay, like but yeah, this in this course, yeah, we say that tangent doesn't exist.
Does not exist.
Yeah.
Okay.
Because in that case the slope is infinity, right? That is the problem.
Hello.
Yes.
Yeah, hi. This is activity 7.2, question 4. I'm a bit confused what is going on there. 7.2, question 4, please. So sine of x plus y is given as sine x times cos y plus cos x times sine y. And x is greater than 0 and y is less than 90 degrees. So I know the first one is right, is because I know that a trig identity such as that exists. Sine 2x is equal to 2 sine x cos x. But I'm not quite sure how to derive the remainder. I'm just not clear about the whole question actually.
No, this is given, right? You have you have this equality, right?
Yes.
So in the first equality, so you basically it's asking you whether this equality holds or not.
Yes.
So as you can see, you want 2x here, right?
Okay. Yeah.
So with the sign, you want 2x here, and if you replace y, if you replace x in place of y, so here you will get 2x, right?
Okay.
So then what you should get? Sin x.
Yeah, cos x.
Cos x.
Plus cos x sin x. Yeah. Oh, that makes a lot of sense. Yeah.
So now you know the value of sin 2x, right? So similarly, you need to substitute
right,
and get the value of sin 3x.
Right.
But sin 3x, I'm unable to get. If possible, can you show, please?
Okay, let me do it.
So it will be sin x plus 3x, which will be sin 4x, correct?
No. You see, now you want here. Now you want what? 3x, right? So if then one you have to take x and one you have to take 2x.
Oh,
y
like
equal to 2x.
Okay. So y is 2x. Okay.
Yes. Then only you will get
3x. Yeah.
3x.
Sorry, that
so
was
you want 3x, not 4x. So
correct. So that will be sin x cos 2x. Correct.
So yeah.
Sin x cos 2x. No, sorry.
Sin x, you are correct. Sin x.
Yeah,
sin x cos 2x cos x sin 2x.
Yes, correct.
I'm unable to get the value of cos 2x. That's where I struck actually.
2x, right?
Yes.
So now, so it's basically saying that sin 3x
it should be equal to 3 sin x minus 4 sin cube x. That's the equation.
Yes. So sin x.
Yeah.
cos 2x. So here, so we know what is sine.
Oh, like 2 sin
2x.
x cos x. Oh, okay. So I can say cos x times 2 sin x cos x. Yep.
Right.
And then sin x comes common.
Yeah. Then what you do? You take sin x common.
Cos 2x
plus 2
cos x. Cos square x, yeah.
Cos square x.
Yeah.
Okay, I guess
from here I'm unable to do.
Yes. I
I'm not
understand.
good at the properties of trigonometric functions.
So okay, I can see one thing you can use that is basically what?
So these equations we learn in 11th or 12th, 11th.
Yeah,
I think.
that is fine.
We should memorize this.
Actually, you okay, I guess you have to memorize these things because
then all these things we need to memorize.
This and all we forgot, sir. To be very frank.
So
sign and all you don't
actually,
give,
I took
or
a
you have to
printout
state it in the question paper itself.
Okay.
Better because this is impossible to remember, sir. I am 78 born.
No. Okay. I agree with all of you. Okay, so it's better if you. I agree. Yeah. And also there is no point.
Till here I solved, but here I don't know the property of cos 2x plus 2 cos square x. So I struck here.
No, I agree that this question 4 and 5 are quite related. Okay, so
and later questions also depend on the properties of the sine cos questions are there.
Yeah, so basically what you have to use now, two things. Cos 2x is basically
cos square x minus
sine square x, and the second thing you have to use that sine square x plus cos square x is
equals 1.
Yes.
So then you can get the thing.
But
okay, so
sir, these formulas are not mentioned anywhere, even in the lectures, and also in the...
no. This one is mentioned in the lecture. That I'm
this one is mentioned.
The sine square x plus cos square x equals to 1 is there, but
this one is mentioned in the lecture, and
other things we need to
and this one okay, this one is mentioned in the question number 5. Okay, so as I said,
otherwise, if possible, can you publish a page with all the formulas, especially for the calculations, what we need?
No, in the question itself, you can.
So the thing is, okay, the main problem is there is no such formula. Like there are so frankly, you can create infinitely many formulas from this.
What do you use here?
Sandy, I can tell you something. You can take a printout from the Google 11th grade mathematics trigonometry, last 2 or 3 pages. You will get all the equations about trigonometry.
No. I think the question is more deeper. The thing is, as sir said, there's an infinite number of formulas that can be created.
See, these
basics
can be avoided, right? You can avoid all.
No, I think we should solve this question based on the periodic functions. It is not necessary to use the formulas, I think.
No. Okay, certainly I don't agree that this type of question should avoid it, because okay, these are quite essential thing so that you can.
I'm not denying that, but you can gradually you can introduce a trigonometric week and then introduce this type of question. That will be
no.
meaningful.
Okay, so okay, so let me tell you, we are not as you can see, we are not using much trigonometry function. Okay, so we are using very few things. Okay, we are not using like some kind of
okay, so sorry, you can move ahead.
Yeah,
that's what I thought, and I left these questions. That's what I thought.
I agree with you that certainly it's better to always mention this formula in exam paper, because I don't see any point of remembering all these things.
Correct, sir. Correct.
But again, you should, so the thing is, you should
remember is useful for me, sir.
Sorry. Okay, remembering is not
But
that
it
useful,
is
at
not
least.
possible within 1 month. Our whole plus two
Sir.
portions we cannot remember them.
Excuse me, sir. Can you give us? Sir, I
Okay,
have
so
a more
let me tell you one thing. Okay, I'll inform the team to always mention the formula when they are asking trigonometric question in exam. Yeah, that certainly I can.
Actually, sir,
Yeah, then it will be very helpful, sir.
Yeah.
Yeah, also I have a more fundamental question, sir. Let us say, I don't believe in remembering formulas. What I want to know is, how did you come to know, sir, that I have to apply this? That is what I want to know from you. How do I approach this question? How do you approach this question when you're solving it? That's what I want to know.
Okay, so the thing is, okay, that certainly, okay, if you so when so it's mostly it comes with practice. Okay, that is the only thing I can suggest you, because I also struggled on all these things when I was in class maybe 10 or 11.
Got it.
Okay.
We all did. When you memorize more, there is a chance to forget. So it's always good to memorize less and learn concepts more.
No, okay. So the thing is, few things you have to memorize. For example, sin x by cos x is tan x.
Yeah, of course. Okay, I mean, even the Pythagoras identity, that's very obvious.
Yeah. So these
whatever
type
is
of
required, we will memorize for sure.
So few things you have to memorize, but I don't
Sir,
see any
these
point
are
of
all first principles, sir. Sin theta equals opposite.
Yeah.
So these three are opposite by these things are all you can derive itself with the example. But this type of long and all, it is very difficult.
Yeah, I agree.
Sir,
but,
just to complete.
I'm not expecting someone to use for example this formula to use this formula in exam. Okay.
Yeah, exactly.
Okay, certainly I am not expecting.
Next question is that is only cos 3x.
Same. You have to go through the same process. Okay. But what is actually like the problem is, okay, so the problem, what is my problem? I think you cannot solve this question just by using this one. That is the main issue with this problem.
Yeah.
Okay, because it's given, but at the same time you are using this cos 2x formula. Okay.
Correct.
So that is I guess it's the problematic part in this question. Okay, you cannot do it by using this formula and this formula. Okay. Yes, that I agree.
Okay.
Because it's given, so because it is given in the question, but hardly you should use this formula to get your answer. But again, you are using something from question number 5. Yeah.
True.
Yeah, we'll try to change this one. Okay.
Yes, sir. Also, sir, a follow-up question. Why are some questions at the graded assignment marked 0 on the thing, like 0 points? There are some questions which have 0 points in the graded assignment.
Is it like, no, I guess you will get your mark after the re-evaluation. Okay, so you have to wait 2-3 days.
No, I'm not talking about my responses. Like, after every question, there's 1 point, 1 point, 1 point, like, for weightage for every question, right? So there are, so if you look at graded assignment question 1, it is for 0 points. Now that usually happens if there is usually a mistake in the question, or I don't know, but I've checked the announcements. There are no mistakes as such. So I'm just wondering why that is.
You are in week 7.
Week 7, graded assignment 7. Yes.
Sir, I remember once sir told like that it is like a previous past paper question or something like that. You have to practice. If you are not doing the question, then also no problem. Like that they told. It is for a
yes, sir. Maybe it could be for the practice.
Maybe it's for practice.
Yeah. So if you want to attend, you can attend, but there is no mark for that question.
Okay.
Okay, it is like that. Once some instructor told like that.
Achha.
Yeah, earlier also in some graded assignments, many questions are marked as 0.
Achha. Okay.
Yeah, professor also told that it could be for your practice more and more questions.
Okay.
It's up to
okay.
you. You can attempt also. You can't even.
Okay. It's just very strange looking at it as a graded assignment.
Yeah. Yes. I guess. Yeah. Maybe it's for practice. Even I also.
Or yeah, maybe it's for practice, or maybe it could be some miss also.
No, certainly it's not a mistake. Like
no, it is not a mistake.
Or it could be a clue to subsequent questions.
No, it's not a clue to subsequent questions. It's not. These are standalone
No,
questions.
no, I remember one instructor told like that only. Resemblance of a practice and a graded assignment, no, for the qualifier exam or something like that. That kind of exam, the questions will come for the exams.
I guess this is the correct reason. Otherwise, you can okay. Like I also don't know what is the reason. Otherwise, you can ask maybe Vicky or Srikant. They can give you the better answer. Why actually they have.
I think once Vicky sir only told like that.
Yeah.
Then surely for the practice assignment, just for practice.
Okay. Sir, also I have another question. In the lectures, Professor Sarang Sane mentioned that I didn't quite understand what he was trying to say when he said that the definition of a tangent, and when we learned in grade 12, definition of a tangent is where it just touches at one point, right? A curve, a tangent touching at just one point. And he said that that technically is not true.
Not true.
Yeah, I just didn't understand how it is not true. Could you please some light on that? I know it's already 9 o'clock. Could you just spare 2 minutes?
No, that is fine. But the problem is actually there is a definition of tangent actually. That basically you can define. So as you increase the level of the subject, then the definition of the tangent will become finer and fine.
Okay.
So the thing is okay. So for example, if suppose my graph is like this.
Okay.
This is my graph. If so, suppose I am taking this point. Actually, you have a tangent in this point.
Right.
Okay. So, and if I draw the tangent, basically it touches the curve more than one point at this point and as well as this point.
Right.
But if you use that definition, then by that definition, this is not a tangent.
Got it. Yes.
Okay, but technically it's a tangent.
Right.
Okay. So basically, tangent tells you about the function which is very much near to that point.
Okay. Right.
Okay. Right. It will give you all the information. Like it's a approximation. This is a approximation of the function near to this point.
Right, and you could say local maxima or minima like that, right?
No, it's not local. No, you can actually get local maxima and minima using the derivative, basically the slope of the tangent. Okay, but you can get it, but yeah, it's basically it's more or less it's a relative thing. Okay, sometimes
sir, this line is tangent of point P only, no? The other point it is not a tangent.
No. It certainly it's not a tangent at point Q.
Okay.
Just a quick follow-up.
It basically tells the direction of the graph at that particular point.
No. It's basically no. I don't think it gives you. What do you mean by the direction of the graph at that point? So,
I mean, in which direction this is moving? Like,
no, it's basically it's moving in both the directions.
Sir, a quick follow-up. If the function would be strictly increasing or decreasing, at that point it would be like if that definition would hold, right? If it's a strictly increasing or decreasing function, in that case, I think that will only touch at one point, no? If this definition.
You are saying if the function is strictly increasing or decreasing.
Like say for example an exponential function, say for e raised to x, right? So in that function, if I have a tangent at one point, I think that definition will hold, right, sir?
Okay.
So it's e raised to x, yeah. Correct. And here it must definitely touch at only and only one point, like like that.
Yeah.
Okay. Got it. So that was really helpful.
But okay. But I'm not sure whether it holds for all the increasing and decreasing functions.
Because I'm thinking of say 1 upon e raised to x, or even minus e raised to x, or minus e raised to minus x. I mean,
Yeah.
these are strictly increasing and decreasing functions, and even a log function, to be honest. I mean, there could only be one point at which they could meet. Like, I mean, I can't see, I can't imagine they're not meeting at any other point. Like,
maybe say this one.
yeah.
Yeah,
I mean, here
yeah,
also.
yeah, certainly here also. But the thing is, okay, so
Yes, sir.
The graph of a strictly increasing and strictly decreasing function can be very well. Okay.
Oh, okay.
You may not get this kind of smoothness everywhere.
Achha,
okay.
achha.
So like,
Okay.
yeah, you can draw it easily, but like it can be anything. Okay, there are maybe your statement is correct. Maybe I have to think it properly, but still I can say that your statement is correct. Okay, but I'm certainly at the same time I'm not saying it's wrong.
Yes, sir. I understand. No, I understand completely. Yes, thank you.
Yeah.
Yeah, EQ 7.4 question number 1.
7.4 question number 1. Oh, I guess I have already discussed this question.
Okay, I'll check.
Yeah. Regarding this sequence, right?
Sequence.
Yeah, I have discussed.
Sir, regarding logarithms, I have a doubt, sir. Shall I ask?
Which one? Like,
sir, expression like log 3 square.
Log 3 square.
Log 3 square can be written as 2 log 3.
Yes, true.
And it can also be written as 3 log 2.
3
log 2.
No. How?
Because in last graded assignment, last question, it is like that m power log some function they have given 2 at the power.
Log 3 equals to 3 log 2. We can write now. There is a formula is there.
Sorry?
No, actually it is a to the power of log b.
Have you checked the solution? Like,
yes, the solution also I have a doubt, so that only I call you.
It's 2 power log 3, right? It's not 2 log 3. 2 power log 3.
Sorry, 2 power?
Log 3. We can write it as 3 power log 2.
Yeah, maybe
the last
this you
question.
can write.
Yeah.
But certainly this is not correct. Like, log 3 square is basically 2 log 3. That is, I agree, but it's not equal to 3 times log.
Okay, sir. Right. I understood that. Okay. Only power I didn't consider. It is.
But that last problem,
I thought that it
you
is.
have to use this power.
Okay.
And actually,
Right.
one doubt I have with logarithms. Can I?
Yeah, please.
When we plot a graph, log x square graph is different from 2 log x, right?
No, so the thing is, okay, there is the.
We can write log x square as 2 log x.
No. The problem is different. No. Okay, so the problem is these are two different functions. Okay, these are two different functions. For this function, okay, the domain is R. But for this function, the domain is positive real number. And in R greater than 0, for all positive real number, if x is greater than 0, then they are same. Okay, so there is a difference between both the things. Okay, this is a different function. So as you can see, this is defined over all real numbers, right? Log x square. But this is not defined over all the real numbers, because log is not defined for negative things, right? So they are two different things. The domain for this function, the domain is R. For this function, the domain is positive real numbers. Okay, so then certainly if you draw the graph, then you will get a different graph, right?
So whenever the log functions came as a question, we should not alter it as it is. We should plot. That's better.
Yeah. So as I said, they are two different things. Okay,
Yes,
they matches on the positive, on all the positive real numbers, but this is, see, this log x square, it's a map. It's a map from R to R, right?
Yes, yes.
But this 2 log x, it's not a map from R to R. It's a map from R positive to R. So when the domain of these two functions are different, then obviously you will get two different graph, right?
Yes, yes.
So they are different as a function. Okay, so certainly then they will have two different graphs.
Okay. Actually, Shubham, we are not enabled to cope up with this math syllabus. Actually, after week 6, it's really difficult to learn all these things within a short period of time. So that's why I requested several times to keep extra sessions to revision, especially weekly 1 session for revision. I wrote in the forum, and before earlier 2 sessions also I requested to keep sessions. Many students requested.
Even we also requested.
All
very
requested.
difficult to do.
Any improvement?
For especially for the activity and practice, assignment practice.
No, I agree with all these things. Okay, so the thing is, the main motive behind this course
till
is
5th week we can do at least without any doubt and all, we can do activity questions, sir. But 6th onwards, it is like it's very difficult.
1 week, 1 session, if you dedicate for session revision, that's helpful for the students.
No, certainly now we are taking 3 sessions, right?
But where we are revising revision?
No, I'm not saying that we are revising the things, but you want that we should take one more session and revise all the things.
Okay, keep the session within these 3 sessions. Please dedicate one session, at least 1 hour for the revision.
Okay, certainly in more or less in Solve With Us, we do so Solve With Us is basically a revision session, right?
So whoever know the concept properly, they can do in the Solve With Us.
Because what's happening when comes to this limits, logarithms, when we go through all the presentations, videos, tutorials, everything, but still we are not clear with the concepts.
Yeah.
Yes, sir.
We cannot do the question, how to approach the question. We didn't understand actually.
So,
sir, can I make one suggestion, sir?
Example, when it comes to the bounded and unbounded function, there is an example in the video and a few examples were there in the tutorial and even in the video. But see, it took half an hour for students like me to understand after you explain in detail also. There we are lacking, actually.
Okay,
so we need a revision session. Actually, you keep this session only anything for revision. You start doing revision at least for 1 hour in the starting of the session instead of taking the questions and explaining.
No, actually, what madam
हाँ
is
सर,
saying is
computational thinking वाले सर भी करवाते हैं वैसा same.
No, okay, so generally we do similar kind of thing in maths too. Okay, so
can we?
Or math is just a fifth subject, sir.
Sir, especially like the approach to solve a question, I think that is where everyone has lack of confidence, like how to approach that question. That itself will build the that itself will clear the fundamental. That itself also will build the clarity in understanding the question, how to approach.
Really, now you explained bounded, unbounded questions, so we are very well understood. But by watching the videos, it's not clear.
It's really difficult to, I am not even it's really difficult to how to approach the question. Like when you're seeing the question, oh, it's something different, video is something different, and there is no connectivity between the videos and the question what we're getting in activities and all. So like whenever same people, like keep.
No, there is connection, but yeah.
Yeah, theoretical part is clear, sir, but how to approach the question that we are not getting from this thing concept understanding.
Making us like we don't know anything or something like that.
No, that is fine. See, the thing is, okay, so let me tell you one thing. Okay, you are basically learning a lot of things in a very small time. Okay, so that certainly is true. Okay, because see, the main idea of this program is basically you should spend more time on programming. Okay, if you spend a lot of time in mathematics, then you cannot do much courses in programming. Okay, so okay, I agree that you are like, it's better if we take some revision session in 1 week. Okay,
I don't want to discourage you guys, but statistics,
No,
computational thinking, they are doing revision in the sessions now. I don't want extra session, but they are doing the questions, but they are revising also. Entire week content they are revising in 1 hour like that.
Okay.
Sir, we can understand maths. We cannot
I'm
complete like that.
No. I'm taking all of your suggestions seriously, and see, certainly.
actually,
okay. Again, I have to
It's
inform
very
Vicky
vast
and
subject. We can understand.
I have to.
When Vicky comes, when Vicky comes, really, I should appreciate. He used to revise always.
No,
He
same.
used to.
Actually, what she is telling is the same thing. For example, this week content, you please summarize for 1 hour. That is what she is trying.
That's what
I am also.
Sir, okay, everybody, please. Sir, मेरा एक question है इससे थोड़ा हटके.
No. Okay, so let me tell you. Okay, just a minute. Okay, I'll see. The thing is, okay, I'm not. Okay, certainly, I'm actually more related to maths too. Okay, I'm not much related to maths one. Okay, I will discuss with Vicky and this Srikanth. Okay.
Sir, I have a question apart from academics, sir.
Okay, no. Okay, just a minute. Okay, let me complete my thing. Okay, I'm not saying that you don't ask your question, but just a minute. So I'll discuss with them regarding all these things, whatever you said, right? Like in each and every session, we spend some fixed amount of time on revising the things. Okay, the things.
Apart from solve with us, we have 2 more sessions you are conducting anyway. In this sessions.
Yeah. I will inform you.
Actually, if you summarize for that week's content,
yes, I'll discuss.
Be very useful. Actually.
Yeah. I agree with all of you. Okay, I'll discuss with Vicky and Srikanth.
Okay, fine. Thank you so much.
So probably in next session, they may tell you something regarding this. Okay.
Yeah, but thank you.
Sir, in addition to this,
sir, my question, please.
Sir, in addition to this, we don't have solution to the activity questions, and before it was okay because they were more of a simpler nature that once we watched the video we were able to solve it.
Okay, so the
but
thing
now
is, okay.
we can't do
no,
it. So
okay, let me complete this.
We're
okay.
Clueless.
I have a certainly I don't. Okay, actually many of you are in maths too. Also, many of the student, they are asking for activity question. Okay, see, the main point is, okay, I also learned all these things. Okay, I'm telling you from my experience, giving solution is not at all a good solution to tackle this problem. Okay, because once I give you the solution, you will try it for once, then you will go and look at the solution. Okay, and by looking at the solution, you can only solve that problem. Okay, if I'll just change the question, then you cannot solve the problem. Okay, let me tell you, this is a normal issue. Okay, I faced.
I fully agree with you, sir.
This lot of times. Okay, I can give you the. See, the thing is,
once we see the solution, we tend to.
Okay, you have to understand that we are spending more time on solving this question. We are taking 3 sessions. Maybe if you combine all the things, then it may go more than some 8 hours also. Okay, within 3-4 hours we can prepare all the solution. Okay, so you have to understand that why we are solving more, spending more time on discussing all these things rather giving you the solution. See, the solution is not at all a good thing to do, because see, basically once I give you the solution, then basically you'll try it for once. Okay, and if you can't solve it, then you will go and just look at the solution and then you are done. Okay, and again, if I'll simply change the solution, then you cannot simply change the question, then you cannot solve the question. Okay, that is the main disadvantage of having solution.
So for that, you have to have discipline. And for me, at least, I don't look at the answer before I've attempted it.
Yeah, so
it's all about discipline.
Yeah, that is true, but that percentage is very less. Okay. That is that certainly you cannot disagree.
Sir, my question, sir, please, sir.
Yes, yes.
सर मैं पूछ रहा था हिंदी में बोलूँ ना?
Yes, हाँ.
सर मैंने इंटर का एग्जाम दिया था, तो मतलब मेरा 12th कंप्लीट हो चुका है इस बार. अब मैंने अभी तक किसी रेगुलर क्लासेस जैसे होते हैं ना, ऑफलाइन में एडमिशन लेते हैं, तो उसमें ऐसे किसी में एडमिशन लिया नहीं था. मैं बायो स्ट्रीम से हूँ, और वो अभी मतलब काउंसलिंग तो चल रही है, मतलब किसी में एडमिशन खास लिया नहीं है अभी तक. तो मतलब अगर ये 12th के बाद सीधा ये कोर्स कर रहे हैं तो फुल टाइम तो मिल रहा है, लेकिन मतलब कुछ ऑफलाइन भी करना जरूरी है क्या, मतलब कोई रेगुलर क्लास?
Okay, certainly okay, this I don't know the answer of this question. Okay, but it's basically it's up to you what basically you want to do in your life. Okay, so see, if you want to do this seriously, then you can proceed. I don't see any problem.
No, but sir, sorry to interrupt. There is a issue because he just passed out the 12th grade, no? So he has to join some university.
There is a rule is there.
Yeah, the second term they will ask the identity card or some proof he is a regular college student.
Okay,
They are asking like that.
Okay, then
No, it is not. It is AICTE and the university. You know, whatever university departments rule. It's from the big head. It's not even with IIT. It's way above IIT.
Yes, sir.
So you need to join another college.
Okay, then I guess yeah.
Mandatory
so you
requirement is there,
got your
sir,
answer.
advice.
Okay, maybe they to continue in this course, maybe they are asking your ID card from some other institute where you are doing a offline course. Okay, then it's
No, full time.
That is offline.
Yeah, regular course.
Yeah.
Full time.
Yeah, full time. Yeah. So then you should join somewhere. Otherwise, I guess you cannot continue here.
Thank you, everyone. Thank you, sir.
Yeah. Sorry, actually, I didn't know this.
Sir, can you give some additional improvement assignments, sir, graded assignments? Because now we are getting some confidence, sir, but time is not there.
No, if time is not there, then how you'll solve the additional? See, frankly, okay. So
we are getting some idea, and we are now getting some control.
No, frankly, whatever assignment we are giving, that is, I guess, is see, we are giving lot of questions.
True. No. In that way, no. A lot of questions are there. A lot of.
But I don't know. Like, I guess once you solve all the questions, obviously you should understand the concept also. Then I guess you should able to do well in at least in exam. So,
sir, actually, one thing, sir, how to bridge the gap between the conceptual understanding and the question? Because really, I feel inconfident in this, because after spending too much of hours in the videos, when you are coming to these questions, and I'm really becoming clueless how to connect these two connective points, and that itself not boosting the confidence.
See, all the things basically it's a continuous process. Okay, see as I said, the question, see all the things whatever I have discussed today, see the 6.7.1, 7.2 and 7.3, except few questions, all the things actually it's depend how you understood the concept of week 1. Okay, if you know the concept of week 1 pretty well, then basically you can solve almost all the questions of 7.1 and 7.2. Okay, apart from few tangent questions. Okay, it's basically everything is related to the set theory. Okay, so as I said, it's a continuous process. I cannot give you in a session how you can tackle all the questions. Okay,
question में तो नहीं होगा, but actually we need to have some ecosystem where we can.
Yeah, so that is the thing. Now you have to practice more. Okay, so again, one more
practice
thing.
करने के लिए, like whenever I just make out my time to sit for the practice thing. I don't know why to begin and how to begin. So that there itself I will just stop. Like I make my time, like I sit for 8 hours, 10 hours. But when I sit for practice, how to begin, where to begin, I'm really getting not getting clarity clue how to begin that one. So like after watching all the videos also, this is the difficulty which I am facing. Like that connectivity is lost. As you said, like okay, if you're giving the steps.
So so are you from mathematical background or like?
Yes, I am from mathematical background. There is no, I really understand that things very well. But main thing is that after watching the video, the related questions, if it is there, so we can just go gradually step by step. Okay, this is what it taught in the video. So based on this is the question. So once we learn that, then we'll keep on gradually build up that concept and we come to the complex questions. But what is something different is there. So that
my question is how many questions you are solving from the activity part on an app?
Every time, like very few of them I'm able to do. Like you can say for 50% I'm able to do, and yes, 50% I'm not able to do.
No. If you are doing 50%, then I guess it's fine.
मुझे लगता है कि 100% नहीं करेंगे तो वो confidence नहीं आता कि चलो आगे एग्जाम
No, see the thing is okay, no, if you are able to solve 50% question, I don't think it's a big problem. Like you can actually you can improve the percentage day by day. Okay, so if, in the beginning, if you are able to solve 50% question, then I feel it's not bad. Okay. No. See, the thing is, okay, so many of you are doing all these things after a huge gap. Okay, so I guess that is not an issue. If you are able to solve 50% question of the activity part, then I guess you are doing pretty well. I guess in the end of maybe after 1.5 week or maybe 2 weeks, I feel you can solve maybe more than 75%.
Sir, related, may I ask you a question, sir? So related to the same, like I have a queries with regard to the same thing. Like we have for week 5, one-to-one function, the natural exponential functions. So somewhere the people who have lost the touch with maths and they have also like working professionals. So can you just tell us like because first the very first hurdle becomes we don't have a connectivity in between. So how to just cope up with it? Any tips can you give us to us? Because the more the complex whenever the sums are there, when we read it, the fear only comes. So how to just tackle the thing?
No, okay. So let me say it clearly. There is no shortcut for it. Okay, so you have to whatever problem you are facing, the only way you can overcome this is by doing more and more problems. Okay. As far as I know, there is no other shortcut.
And are we having till week 9 for maths or till week 8, sir? For 13th April exam? 13th March exam?
Week 8.
Week 8.
Yes.
Okay. And for the final one, will be having?
Sir told last week, week 9.
Week 9?
Yeah.
Okay, I don't know then. I have to.
Guys, somebody remember that?
Yes, I do remember. Vicky sir told it will be only for math.
Yeah, for maths, it's till week 9. So we are in trauma only.
But okay, one thing, sir, we have to appreciate success of the program lies with you instructors. Because watching video.
Okay, so I guess okay, I guess we have.
Vicky sir को convince कर देंगे नहीं 1 to 8 करिए 1 to 9 मत करिए.
No, I don't know.
To have till week 8 only.
No, we'll convince him, sir. Please don't make fun.
Even the practice assignment are not having solutions from week 7 onwards.
No, week 7 onwards. No, week 7 you have solution.
But it is not showing for practice assignment.
There is some kind of resources from instructor.
Oh, okay. It is embedded over there.
Yeah.
Okay.
It's there in that folder. Yeah.
Sir.
Okay.
Hello. Sir, I just want to know which is the best reference book for this logarithmic functions and limits.
Limits.
See, like algebra, they have given this EKR English.
I guess
So
you should see this CBSE books, I guess.
11th standard math books.
Yes, where you can get all the concept of limits and
Sir,
continuity.
can I also suggest one more book? There is a curriculum called as the IB curriculum. And in IB curriculum, you can get the textbooks, the PDF of those textbooks for free on pdfdrive.net. So I highly recommend, if people are looking for reference material, go to IBDP Maths, just Google IBDP Maths HL and download the textbook from pdfdrive.net. It's really helpful as they break the concepts down very nicely. So if any of you want to take a look at that, I think it will be very
Can you
helpful.
repeat the site name?
Can you write it in the chat section instead of saying?
Yeah, I'll do that. I'll do that right away. Yeah.
Okay, thank you.
Okay, so yeah, please. So I guess he send you the link. Okay, then shall I close the session?
Yes, sir.
Sir, so one last question and a quick question. And this is got to do with the qualifier exam. A very general question, sir. How do I find the C value in a sum squared error question? And I'll tell you, the reason I'm asking this is because I was under the impression that once you solve the sum squared error questions using the data points that are given to us, you eventually land up with a quadratic, and then you basically, find the minimal point of the quadratic. You see b square upon 2a, the minimal point. And that's what I did in my qualifier exam, where there was a question about a bridge and a river flowing. And my answer came to 9. And the mark scheme of that question said the answer is 12 or 15 or something like that. And I'm not quite sure. I don't know if you have the question or.
No, okay. I don't. Okay.
No, this question was discussed before the exam itself.
I have not seen the qualifier question. Okay.
You can see Vicky's video. Actually, this question was discussed before the exam itself.
This question was discussed?
Yes.
No, I'm talking about the qualifier exam. This came in the qualifier.
January, right?
Yeah, the January 30th.
Yeah. That's what Vicky disclosed this question before the exam, and he has solved it.
Okay.
Question, similar.
Almost same and same almost. Yeah.
Yeah. Then you should go and check the session.
Okay.
And one more small administrative thing, sir. Okay, sir, don't take so much time to publish the results, quiz results.
No, that is actually, it's not in my hand. Like, okay, so I cannot do anything on that because there are so many things.
Because we have to budget our time actually. Once we know which subject we are weak in, we have to put some more time.
No, actually, the thing is, it's not that easy also publishing the result. There are so many students. Okay, first of all, I don't handle all these things. Okay. So I have no idea regarding the result. But as far as I know, yeah. So I guess what from our discussion, yeah. So it's not that easy to, because last time they published the qualifier result first, and after that they published this diploma and degree result. Okay, so the qualifier result, certainly they are giving the first priority. Okay, so
now the reason is we'll come to know which subject we are a little bit weak in, and we can put some extra time.
I don't know. I guess like certainly we have published the result like maybe some 4 or 5 days, or maybe hardly within 1 week.
2 weeks, sir.
2 weeks.
Yes.
Okay, maybe, yeah.
Or you can give the answers key and also what we have inputted in the computer now. That answer sheet also, if you publish, that's enough. We can.
No, that I guess we have shared within.
No, you have given only the solution, means the answers. But what we have fed, that one you have not given. You gave only after 2 weeks. I mean, you means the. We didn't get
that I know. Yeah, certainly I don't. We instructor don't deal with this result things. Yeah. Okay. Maybe this time I feel got delayed. Okay, then yeah. So okay, I'll stop the session. Okay.
So I think we'll just request you to just clarify on the part that is it going to be till week 8 or week 9 so that we can plan accordingly for maths.
Maths 1, right?
Yeah, maths 1.
Okay, I'll okay, again I have to ask Vicky and Srikant, then only I can tell you about this syllabus. So in maths 2 actually it's week 1 to 8. So I thought in maths 1 also it will be from week 1 to 8. So that's why I told okay it's week 1 to 8. But someone said that in last session Vicky told that it's week 1 to 9. So again I have to ask them.
Okay, sir, fine.
Okay.
Thank you.
Yeah, thanks.
Thank you very much.
Thank you, sir.
Yeah, thanks.
Thank you.
Thank you, sir. Thank you very much, sir. Thank you, sir.
Yeah.